So we have another example problem here. Light from a helium neon laser that has a wavelength of 633 nanometers passes through a narrow slit and is seen on a screen 2 meters behind the slit. The first minimum in the diffraction pattern is 1.2 centimeters from the central maximum. How wide is the slit? All right, so the wording here, this light passes through a narrow slit, means a single slit. They've given us the wavelength of the light. We see this pattern on a screen 2 meters behind the slit. That means that is L. The first minimum means P is going to equal 1. Y1, it's telling us where that first minimum is seen. And we want to know how wide the slit is. That is A. So if we go to the single slit equation that relates Y and wavelength and L and A together, it's this Y sub P equation. P is a multiplier. It's using P instead of M since P has to start at 1 and M started at 0. Since we're talking about the first minimum, we want P to be 1. So if you recall or look at the test notes, the equations that are listed have to the right dark fringes in parentheses. So Y sub P here tells us where the dark spots are located. So the first minimum is Y1, and that occurs when P is equal to 1. So here we're actually just looking for how wide the slit is. That is A. So we have 633 nanometers. I'm going to put everything into meters. Just make sure you watch your units. Y1, 0.012 meters. Oops. So my calculator, let's see, we have 2 sig figs. So my calculator is telling me 0.00011. It would be appropriate to either put this in scientific notation or write it in terms of a prefix. Since the question doesn't specify what units to leave it in, either one would be appropriate. So look for the wording in the problem to determine which equations we want. It's interference, so we just needed to know if we had single slit or double slit or diffraction grating. And then remembering what all the different variables represent, we can put everything together.